Framework for network design decisions. The global network design decisions are made in 4 phases. Below, each phase is explained in greater detail with real-world examples. Phase 1. Define a supply chain strategy/design. Objective: set the overall supply chain structure to support the company's competitive strategy. Decide whether functions will be in-house or outsourced. Key activities: define competitive strategy, supply chain capabilities, and forecast competition. Identify constraints like capital and growth methods, for example, new facilities or acquisitions. Example: Apple focuses on premium products with a global supply chain strategy, outsourcing manufacturing while handling assembly in-house. Phase 2. Define regional facility configuration. Objective: determine where to locate facilities based on demand, economies of scale, and regional risks. Key activities: forecast regional demand, analyze economies of scale or scope, and assess regional risks, taxes, tariffs, political factors. Example: AMD uses large facilities globally due to economies of scale in semiconductor manufacturing, concentrating production in regions with lower costs and fewer risks. Phase 3. Select a set of desirable potential sites. Objective: select specific potential sites based on available infrastructure and resources. Key activities: evaluate hard infrastructure, for example, transportation, utilities, and soft infrastructure, for example, skilled workforce, community support. Example: Tesla evaluates sites for manufacturing plants based on factors like supplier proximity and workforce availability. Phase 4. Location choices. Objective: finalize the exact location and capacity for each facility based on cost, demand, and logistics. Key activities: choose the best location by considering logistics, local taxes, tariffs, and overall profitability. Example: Coca-Cola selects plant locations by weighing transportation costs, resource access, and local government incentives. Models for facility location and capacity allocation. 1. Center of gravity method. Purpose: finds the optimal location of a facility by minimizing transportation costs. How it works: uses the geographic coordinates of demand points and the volumes to calculate the facility location that minimizes the weighted transportation cost. Application: ideal for choosing a warehouse or distribution center location to serve multiple regions. Here's the formula. 2. Facility location problem, FLP. Purpose: finds optimal facility locations to minimize costs. How? Uses optimization techniques, for example, linear programming, to minimize transportation, construction, and operational costs. Application: balances service levels and costs in large facility networks. 3. P-median model. Purpose: finds optimal locations for PP facilities to minimize total distance or transportation costs. How? Minimizes the sum of distances between demand points and facilities. Application: used in urban planning, healthcare, and retail. 4. P-setter problem. Purpose: minimizes the maximum distance between demand points and the nearest facility. How? Ensures even service distribution by minimizing the worst-case distance. Application: critical for emergency services like fire stations or hospitals. 5. Integer linear programming, ILP, models. Purpose: optimizes facility location and capacity using integer-based optimization. How? Formulates problems as ILP to minimize costs while meeting constraints. Application: used for complex scenarios with multiple constraints and large networks. Conclusion: effective network design and facility location decisions are essential for creating a competitive supply chain that meets customer needs while minimizing costs. By using strategic frameworks and optimization models, businesses can enhance supply chain efficiency, improve responsiveness, and achieve a strong competitive edge in the market. These decisions help ensure the right facilities, processes, and logistics are in place to support both short-term operational goals and long-term growth.